Oh hey, what's up everybody? So for those of you who do not know me, my name is Caleb from Caleb the Video Maker 2 and CalebCareer.com. So I did a design series a while ago. It was my first video series here on YouTube. It was about 25 videos long, and then I went on to make a 67-part video series over MySQL, and I did a couple other ones. I have over 100 databasing videos, and I wanted to try to tackle this again, to try to make it better, explain things better, and also bring you to a new level of skill. So what level of difficulty is this course going to be? It's going to be for beginners. So why do you want to use the series? Most platforms, programs, applications rely on a back-end database. That's how we store information in this world. Everything we do is powered by a database. So it's important that you know how to properly implement database concepts, designs, to know how to properly structure data. So that way you get the best optimized database. That will set you apart from the rest of the IT team or the rest of your classmates. It will give you the skills needed to get that job or whatever you want to do with it. Also, if you're just a business person or you have your own project and you need to learn how to build a website, or you need a database to store all the information you're using, well, this series will be helpful. Basically, database design is the fundamentals of databases. You should know how to properly structure data. This series is not going to be very specific on a certain database management system. So this isn't like MySQL database design. This isn't like Oracle. This isn't SQL Server. This isn't whatever else you use. This is going to be general database design, so then you can take these skills and apply them to any of the databases that you are working on that are relational. Which, I mean, through this series you'll really understand what that means if you don't get that. So the first part is going to be a lot of the concepts on the chalkboard, and I'm not going to write tons of scripts on here, so don't worry, it's not going to be confusing to where you can't see the code on a screen. Because in reality, a lot of database design is not done on a computer first. First you have to think about it, and then you kind of just draw out your plans, whether it be in your head or on a document, or if you use a database design program. I use a chalkboard because I can easily draw out concepts, thoughts, the way data is connected, and all of that. So a lot of these databasing videos, they're going to be on this chalkboard because that's all you really need. We're not programming a database, we're designing a database. And designing is art. You draw it, you design it. So a lot of the concepts from this video will be useful no matter what you will be using for your database. So database design. Before we talk about database design, let's first talk about a database, because we can't design a database if we don't know what a database is. That doesn't even make sense. So, what is a database? That's a really good question. I'm glad you asked. Well, I can actually tell you what a database is, and that's what this video is about. So, a database is something that stores data. Alright, another vague term. Data. And I want all of you to think about data very broadly. Don't think too specific. Think of data as anything we can store in a database, or anything we can write down, anything that has a value. It can be anything. Data can be the list of every single customer of your store since 1995, or it can be a list of every single transaction in a online shopping center, or it can be a list of every user and their username, or it could be a list of every single weather event since 1927. It can be pretty much anything. It doesn't have to do with specific people. Data is so broad. So database is obviously broad too, because a database stores data. So yeah, just think of it like this. Here we have a database. A base is where we store data. Pretty simple. Alright, so now that's pretty vague, and I'm not sure if that was very helpful. So now let's break it down to where we see it from a technical standpoint. Everything in this world, not everything, but almost everything, is ran from a back-end database. It's what stores all of our information. So, for example, I like to use websites for examples because they're very clear and they're very easy to understand the concept of this. When you go to a website and you sign up, you give them a username, you give them a password, and you give them an email. All of that, when you sign in the next time, it allows you to sign in. Well, how did that website remember what your username, email, and password was? That's because all of this information that you put in when you registered, well, all of these values are given to a database. So here you can say is our database. Sorry for my craptastic handwriting, but don't even worry about it. This is what's said to be the front end. This is said to be the back end. That's because we don't necessarily see what's going on back here. We can put in our email, our username, and our password, and it can get stored in this database. That way, when we come back again and we log in, we give them a username and a password, it takes that value, it checks it with the database to allow you to get into the account. That is a perfect example of a database. So a database can store that information, but it's not limited to only registration. You can use this to store all of your records of sales in a store, and all so forth. It just goes on. Don't think of it as a limited thing, because there's so many things you can do with a database. So many things. Next question you may be asking is, how does it differ from like a spreadsheet, for example? So a spreadsheet, basically, if you don't really know much about spreadsheets, it's basically where you have columns, and then we have rows, and we can store information about, like we can enter the values for each column. Spreadsheets are good if that's what you need, if you're a very small company, but if you want to get to any complexity where you can, like, imagine if we wanted to select, let's say this was a spreadsheet for all of my employees. I own a huge business with 100 employees, and I want to select every single employee who has missed less than 3 days and have been an employee for at least 3 years, and I want to give them a $100 bonus. Well, that's something, if I had a spreadsheet, I'd have to manually go through that, check every single value. That's not going to work, because time's money in business. But anyways, with a database, we can run queries to get those kind of values, to figure out which employees have been a employee for 3 years and have only missed 3 days or less. So that's how it differs from a spreadsheet. Basically, what you can do with it. If you have a spreadsheet with 10 employees, or with 10 values, and that's like you can figure out all of your information in a couple of seconds, well, then you might not need a database. That's up to you. The other thing is with spreadsheets, it's either like all data or no data. Let's say this stored every single detail about every single employee that I had, and all I wanted was their name and their address. Well, we can't really do that easily with a spreadsheet unless we take all those columns and like copy and paste and all this extra garbage, or find some algorithm to do things fancily. If you know what you're doing, you can probably do it. But with a database, we can selectively choose which columns. So we can say only these 2 columns do we want returned, and we can ignore the rest. On top of that, we can allow different users to access different information. Back to the website example, we had users page, and then we had a database. When here you put your username, email, and password. That's stored on a database, but that's not necessarily the only thing that's stored on a database. A user might only get to access that, but a database administrator might get to access when they registered, the transactions they've made on your shopping website, or what they've watched, what they've viewed, the comments they've made, how often they visit the web page. It's pretty much limitless to what you want to do with the database. So we can see that 2 different users. This person only gets to view some things of the database. This person can view pretty much anything. With a spreadsheet, it's kind of all or nothing. Do you have access to the spreadsheet? Yes, I do. Well, here it is. If you don't have access, well then too bad, you don't get any of it. So that's awesome. That's a security feature as well, because you don't want this person to get all of the hidden information that's stored within this database. So hopefully that makes things pretty darn clear. The next video I'll kind of be talking about how data is stored in a database, because I was going to get into that in this video, but I kind of ran out of time. But for the sake of just your understanding, if you decide not to watch the second video, which you will watch the second video, right? Relations, that's a term where we get the term relational database. So this series is for what's known as a relational database. That is a specific kind of database, and that's going to be most of the databases that you work with if you're working with database design. We're going to be talking about the relation, very basic, don't freak out, but it is math. We're not going to go super in depth with math. If you want to know more about the math, I have blogs on my website about that. calebcurry.com/blogs. Advertising. Not blogs advertising, I was advertising. Anyways, basically a relation is just a connection between data. So let's just think of a silly example. If we had the two sets of numbers, 2, 4, and then the other set was 6, 8. And then we kind of combined these sets. So we kind of like crossed here, and then we crossed down here. And where these cross is our new set. So we have the combined set of 6, 2, and then we have the combined set of 6, 4, and then we have the combined set of 8, 2, and then the combined set of 8, 4. And like you're probably wondering, like, what the heck does that have to do with database design? Well, somewhat. We kind of do the same thing with database design. Relation in relational database comes from this mathematical concept. But rather than combining sets of numbers, we're combining attributes of real-world things. So let's apply this to the database. First, you need to know two terms. The first one is an entity. The second one is an attribute. So, an entity is anything we store data about. Attribute are the things that we store. So if an entity is a person, an attribute would be their name, their username, their password, their hair color, their address, their phone number, their relationship status, the person they're in a relationship with, the orders that they've made, or whatever it is. It just depends on what you need to store for that specific application. So entity is what we store the data about. Attribute is what we store. When we apply this to this connection with the relation, we have the attribute types and the attribute values. So let's say we have this person over here, and we'll name him Caleb because it's an awesome name. Alright? And then we will also give him a username, Caleb Curry, with no spaces. And we'll give him a password, pi123. And then over here, we have the set of attributes for a table. We have name, username, and password. We can make this connection of data. So the name is Caleb, the username, Caleb Curry, password is pi123. That makes sense, although graphically it looks like a mess. So we store these in tables, which is exactly what we were doing with the relations. So we have up here in our columns, we have the name, and then we have the username, and then the password. Don't worry if you can't read my handwriting, you get it. We store this in a table. Alright? So these are the things we need to connect with this person over here, which we named Caleb, and I accidentally erased them, whatever. We'll just leave it at that. So that's Caleb, and we want to store this information in this table, which is a graphical way to illustrate how we're storing data in a database. So we take his name, Caleb. We take his username, Caleb Curry. We take his password, Pi123. We kind of get this table concept. It almost looks like a spreadsheet that we talked about in the last video. Although it is slightly different, and we'll be talking about that as time goes on. This guy is the entity that we're storing information about. These are the attributes that we need to store about this person or any other person. So we enter specific values for each one of these attributes to make the relation between the attributes and the entity. Hopefully that makes kind of somewhat sense, and if it doesn't, don't freak out. This is complex thought, and you don't necessarily need to understand every single detail to design a database. So I'm just trying to explain things, and we'll get through it. These are the attributes of this person, this entity. An entity is basically just anything we store data about. It's something. It can be a person in this case, but it can also be an order. It can be a customer. It can be a client. It can be a employee, an employer. Whatever it is, it doesn't even have to be a person. So now, the relation idea, you kind of understand that. We're just making the connection between the attributes and the entity. The value, the entity attributes, we're entering that in the database. That's kind of a weak explanation, but honestly it doesn't really matter that much for getting into basic database design. So if you want to learn more about that, just look up relation and database design, you'll figure it out. So now we have the entity over here, and then we have the attributes. So in table terms, you probably know rows and columns. You might not know specifically what they are, and I'm going to tell you. This right here is a row. Can you see that? Might be running out of space here. I think we're good. Yeah, we're good. So all of these values are a row. So a row is all of the attribute values for a specific entity. So this row, it'd be easier just to go like this. This row points to that entity, that person. Pretty simple. A column are all of the values for a specific attribute type. So the attribute type is username. We could have another person, Billy Joe, and his name, his password can be pizza with a U, and his name can be Bill. This is another person in our table. So this is talking about a different person. We have this person over here. See, he's pretty chill. Well, this row is talking about this entity. The username is a column where we have all of the attribute types username. So Caleb Curry, Billy Joe, and whatever more if we put more values into the table. Okay, so this is getting a little messy, so I'm just going to clean it up a bit. Erased. So just to summarize a bit, we have, very first thing, we have an entity type. That's a word you want to know, entity type. Which we talked about entities, I'll just tell you what an entity type is in just a sec. Entity type, and then we have the attribute type. So basically the type means it's a category. So the person was a specific entity, the guy who's named Caleb, That was an entity. It was a person. Then we also had the entity Joe or Billy or whatever his name was. Those were two separate people, two separate entities, although you could tell that they were somewhat similar. They were both in the same table. They were both talking about the username, password, and so forth. So the entity type is user. A specific entity would be Caleb or Bill or Jamie or Jake or whoever it is. So the entity type is basically the category of the entities that we're storing. The category is a user, and all the entities within it should be a user. So my camera stopped recording by itself for some reason, which is super annoying. But anyways, our entity type is the category of entities, such as user. Every single entity should be a user. Caleb was a user, Billy was a user, we could have Jimmy, John, we could have Catherine, we could have Caitlin, we could have Cassandra, we could have, you get the point. The attribute type is basically the categories of attributes. So we had the username, we had the name, we had the password. These are attribute types because we don't actually have a specific value. If, like, no one's name is name. When we actually give these specific values, they no longer become types and they become specific examples. So this guy over here, here's our entity. We can store, so basically, here's our entity. We can store attributes about this entity. The username can be Caleb Curry, blah, blah, blah. The name can be Caleb, and the password can be Pi123. So these are specific attributes about that guy. Now, these are all like complex terms and blah, 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 blah. Who really cares? What really matters is, can you put this into a table for people to understand? Who really cares if you know the terms? But I mean, I'm sure your professor cares, so make him happy. Anyways, in a table, the columns are the attributes. So we could have, for example, an ID, a password, a username, an email. We could keep going, address, phone number, and whatever else. And then a row is where we give a value for every single one of these attributes, all talking about one entity. So like this guy right here. Well, his ID, for example, 72. His username is Caleb Curry. His email is coolguy@hotmail.com. Blah, 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 blah. All of this row talks about this guy. So basically, just think attributes are columns, entities are individual rows. Sweet. Then this whole thing right here, this is the table, and that is the entity type. So the entity type would be user, because every single row within this table should be a user. Oh, another thing I would like to mention real quick, another name in mathematics for a row is a tuple or a tuple. I think it's tuple, I don't really know. But that is another term you will hear. So yeah, tuple is a row. Thank you. So yeah, sorry for like yelling and getting all intense, but it was fun, right? This will be about database management systems, and because this series is over relational database design, it'll be specifically relational database management systems. And we'll talk about the difference. So first, let's just talk about in general, what is a database management system? So this is often shortened to be DBMS for Database Management System. And Relational Database Management System is the same thing except it starts with an R. So it'll be RDBMS. So I'm just going to write that because it's easier. Alright, so where we left off in the last video, we learned, well actually like both of the videos, we learned that a database can be used to store a ton of information. So we have this database, just think of it like a barrel with a ton of information just piled in there. So like usernames and like passwords and junk and transactions, and all this stuff is listed in here. And as you saw in the last video, it looked very similar to a spreadsheet. So what makes it different? We have all this data, now what do we do? What do we do, just look at it? No, don't be a noob. Obviously we do cool things with it, obviously. So, I don't even know what that was about. So what we can do is we can run what's known as a query. So a query, just sort of like searching our data, doing something with it, and giving us cool results. So a database management system uses our data and manages it, allowing us to view it in a human-friendly way and do cool things such as search for values, change the appearance of data, change the way data is stored, and so forth. So, for example, we have 6 billion users, okay, just for an example. And we want to delete anyone who hasn't been active in a year. Well, without a database management system, all we have is a bunch of data, and we'd still have to go manually do all that and delete all that. So the database management system is what allows us to easily run a query, alright, select everyone who hasn't been online in a year, and then we can delete everyone. Who, basically just delete everyone who hasn't been active in a year. Basically, a relational database management system is just a subcategory of a database management system, a specific kind that is designed to work with relational databases. So yeah, not much of a difference there. So just some of the things that these database management systems can do. The first one is obviously run fancy queries to give us specific results, such as give us all of the transactions that were processed before 2011, June 10th. That's something fancy we can do with a database management system. It also allows us to change the way our data is presented. That's something known as a view mechanism. So basically, a view mechanism allows us to change the surface appearance of our data. So when we store our values in our database, we might have it to where we're going to store an ID, we're going to store a username. I'm just going to shorten these up to make it easy. We're going to store a username, we're going to store a password, we're going to store an email, and then we're going to store street address, state, city, and so forth. But let's just say this is how it is for now. Here is the actual table structure for the user table. So here are all of our attributes for a user. I'm going to get rid of this so it's clear. Well, with a view mechanism, we're able to get different views of this data at the surface level. So for example, if we had two people accessing this data, one, let's just name him Jim, and the other one, let's just name her Jamie. Yeah, Jim and Jamie. Let's say Jim, he doesn't really care about the emails, because all he's working on is to find out information about usernames and passwords. So what he might do is he might create a new view of just the username and the password. Once again, I'm just shortening these just to make things simple for illustration. I probably wouldn't put them in the database like that, unless you wanted to, but whatever. So this is a specific view. We can select the username and the password, but the internal structure of the data has not changed. This is still how it's stored within the database. Jamie, on the other hand, she cares about the ID and the email. So she creates a new view, just like that. So these are both called views. So the view mechanism allows us to create different views. This can be used for database administrators as well as for other applications, such as when we have a web page, we may only want users to be able to access their username, password, and email. But stuff such as the date they registered, that might be all private on the database, so then we can just create a view giving them the information that they have access to. And that is a layer of security. So basically, if we have a huge database for a business, well, the database administrator is going to have access to it all. The president of the company will probably have access to it all. But the people who are advertisers, they probably only need to know information about advertising. The people who monitor comments on your website, they are not going to need access to the sales and the transactions. They're going to need access to the table for comments. That's a security feature that a view mechanism allows us to do by giving different views. So not every single person who uses the database has the privilege of creating a new view. Just because you can access the database does not mean you can do things such as update data, change the way it's structured, and so forth. That is probably something only the administrator or the owner of the business is going to be able to do. That means we can allow users on websites, they can only access their specific username and password. They can't access everybody's username and password, only theirs. But if this guy, Jim, who is hired at the company, he can access the username and password of every single user. That's a security difference between the two people, not allowing the user of the website to get too much information, and at the same time not limiting Jim to too little information. So that is a really good security feature. Alright, so what else? A relational database management system allows us to do transactions, which we'll be talking about as the time comes. Basically, a transaction is what it sounds like. It's when we do something with the data that, for the technical terms, basically it is either complete all the way or it doesn't work at all. If we have a multiple step thing, such as transferring money to an account, deducting that much money from the other person's account, and so forth, updating the data, boom, saved. If at any time the power goes out and the server crashes and it doesn't complete, well then the transaction is canceled, nothing is saved. That's something you can do with a relational database management system. So that's pretty much the basics of relational database management system. Just in case you're not really sure of like the terms and stuff, examples of relational database management systems, or just database management systems. MySQL is one. It allows us to build and run a database. SQL Server is one. Basically, like Microsoft, it's run on the server, and then you access it. So you have Microsoft Server. We have Oracle database. We have, I don't even know how to pronounce it, like PostgreSQL or something, and so forth. The list goes on. But basically, all of the big terms that you hear in databasing, they're referring to the relational database management system or the database management system if it's not a relational database. Don't really think of the database and the relational database as two separate things. They're used as one. But if you do want to be like conceptual about things, we have the database, which stores the information, and then the relational database management system, which allows us to manipulate that data. When we have something such as MySQL, we don't really have a difference between these two, and everything's just kind of like, okay, we use MySQL to create the data, it's stored, MySQL is kind of like all we do. The actual files, they're stored on hard drives on a server or your home computer, wherever you're running your database from. And the relational database management takes the data on the hard drive and puts that into presentable tables for people to, like the administrator, to view. Because if we have like a hard drive disk, let's just say this is a hard drive disk, and some of the data is going to be stored like right here. Other parts of data is going to be stored like right here. and some right here. Well, if this is a table, the relational database management system is going to be able to take that and put that in the appropriate location to make it presentable. So don't really think of it like, oh, we have a database and then a relational database management system. Just kind of think of them as one and whole in themselves. So we just have like MySQL. The other thing, finally, I know I'm kind of running along on this video. The other thing a relational database management system is going to do is it's going to create a consistency. I need a bigger piece of chalk here. Consistently, it's going to make consistency behind for the front end. So on a website, we could have someone put their full name in one box, and that can be stored on a database as two separate columns, first name, last name. Well, let's say if we updated this and we decided to make it one column for some reason, which I don't recommend, well, the front end didn't change because the only thing that changed is the back end. With a database, we can have consistency on our front end to make our users happy, never having to worry about things changing. On the back end, the things can change. For example, the way we store dates, or our time zones, or our character sets. Well, that's not going to affect the front end unless the data on here is directly affects the front end. For example, if this is a username column and we delete the username column, well, that's going to cause issues because it's not a column on the database. But basically, when we have a database, the front end is generally consistent, as well as we have server-side scripting languages such as PHP or whatever else. Well, that is going to hide our database an even step farther. So basically, rather than saying, oh, there's no username column, it'll say something like error, try again later. Something very vague so people don't understand, like, oh crap, I can hack this guy because I know his database structure. I can figure out how to mess up his website or his business or whatever. So yeah, that was a server-side scripting language. I'm not going to write that out because it's huge. But yeah, that is the basics of relational database management system. Hopefully that was helpful. This video will be talking about SQL. So, SQL. Alright, so what is SQL? SQL is a programming language used to communicate to a database. Basically, we speak English, databases do not. So SQL is kind of like the mediator between computer, database, and human English. Think of it like that. It's almost English, it's very simple, and in this series we're not actually going to be programming any databases, although we will be talking about general SQL concepts, so it's important that you know about SQL. So SQL is not like a specific relational database management system programming language. It is a general language used for every single relational database management system. From vendor to vendor, such as MySQL to SQL Server or something else, it might vary a little bit, but the general concepts of SQL stay the same. So this is going to be a general concept that you should know about. So SQL first is used to define the database structure. And then it manipulates the data within. So basically we can kind of think of SQL as two categories here. One, it defines the structure, and then two, it manipulates. By that it means we insert data, and then we can search it or delete it or update it. These are the two subcategories of SQL. We actually, for some reason, named these their own languages. So this is Data Definition Language, or DDL, and this is Data Manipulation Language, or DML. Some people may say there's more categories, but I mean this is pretty much the main two. So think of it like this. just going to erase this here. Now that we have this, we have DDL, DML. When we have like a table, for example, I'm just going to write this down here, and we have the columns. So we have like ID, username, password. Well, that's data definition language. Data manipulation language is what we would use to insert a new value, such as the ID of 72, the username of Caleb Curry, the password of Pi123. That's data manipulation language. So when you think of a table, and obviously if you have a big database, you're going to have multiple tables. Well, all of the structure and the connection between tables, that's all data definition language. So it gets all of the main structure of the database, and then the data within the database is data manipulation language. So those are the two main categories. I just want to talk about some of the features of both of these languages. So basically when we define tables, we have a create statement. So basically all SQL I write in all capital letters. That's just a pattern that I've chosen. So create is an example of an SQL command used to create tables, and we can create a database this way. That is data definition language because we're defining the structure of our database. A command such as update, or So update, if we're updating the actual values within columns, well, this is manipulation language because we're not changing the structure. The column stays the same, just a specific attribute of an entity changes. We're updating Caleb Curry's username to Caleb Curry 123. Well, that's a data manipulation language. Another thing that SQL can do is what's known as a join. And joins are very important with the relational database management system. Because with the relational database management system, we break things up into separate tables. For simplicity's sake, for one. Sorry, was I out of the scene there? I think I was in. Whatever. Rather than having a spreadsheet with like tons of information, we break it off by entity. So here's a table about the user. Here's a table about the orders. Here's a table about the customers. Then we can join those values to get a new larger table, a new view that looks like a huge unorganized table. I mean, basically, it doesn't look like we broke it up into multiple tables. So if we have a table here, and then we have a table here, and let's just say we have, this is a sale table, and this is a user table. Within the sale table, we have a sale ID, we have a user ID, the person who bought the stuff, and then we have the objects that they bought. And I mean, this is just a silly example, just for you to understand the concept of a join. And then within the users table, we have the name, the user ID, and so forth. We can do a join here. We could take the objects that they bought, the objects that the person bought, as well as the name of the person who bought it, connected by the user ID. Which we'll talk about this more. Then we can get a new view which has the name and the items that name bought. And it's all talking about the same entity, this user. So a naming convention is just a pattern that people do, or that you do, to keep things consistent. So not only will this naming convention help keep my database consistent across different tables and columns, but this naming convention is not only mine. Other people use this naming convention. That means when I go to a different person to review my database, they already understand what's going on. Now obviously there's multiple different naming conventions. There's not one way to do everything, and it's not required. This is just how I decide to do it, and this is because most people who use MySQL, which is what I learned first, use this. But for different relational database management systems, you may have different systems of naming things. So I'm just going to explain what I'm going to do. Anytime I write SQL, I put it in all capital letters. So, select is an example. Fortunately, we're not going to be doing much SQL, so I'm not going to have to write in all capitals on a chalkboard because it's quite complicated. But when we're talking about anything I name myself, I use all lowercase letters. I just use all lowercase letters because I just think it makes it more simple. So when we have a table, such as a user table, I don't capitalize the U, and then when I have an ID, I just put user ID, or just ID, whatever. But I don't capitalize ID, I just keep it lowercase. And for spaces, I just use an underscore, so I don't use any spaces. So basically that's my naming convention that I use, and yours will vary. And we haven't really got to this yet, so you might not understand this, but if I have a foreign key, basically if I have a connection over here to where we have the same column over here, I just make sure they're named both the same thing so I know what they're talking about. So yeah, some people do things such as put like user table, or they capitalize certain words. And if you want to look at other naming conventions for your specific relational database management system, go right ahead. In fact, I'd encourage it. But just so you understand what I'm doing here, I will be doing that. Another thing, when we're talking about stuff in the real world, sometimes I don't necessarily use that naming convention. Because if I'm writing everything I need to store about a user, well, I might just put, we need to store the user's address. I'm not going to put the underscore users underscore address. I might just put the user's address with space in English. And then when I start making this into a database structure, schema, whatever you want to call it, then I'm going to convert that to just address, lowercase. We're going to be talking about, okay, what is database design? I mean, we talked about what's a database. We never really talked about database design. Why do we have to design a database? What's so special about it that it needs design? It's not like we're building a house or something. Well, in a way, it's kind of like that. We're building schematics to build the best database. How do you measure whether a database is good or bad? Well, it has to do with data integrity, which we'll talk about that in more depth in an upcoming video. So data integrity is basically where all of your data is correct, it's up to date, there's no disconnected data. For example, if we have two tables and for some reason these tables are connected in some way, well, if for some reason this link breaks, well then when this table updates, this table gets left behind and then the data becomes incorrect. That's a data integrity problem because the data is not managed properly. So with a good designed database, we prevent data integrity issues. So all of our data is up to date. We don't have repeating data. We don't have old data that should not be in there. Which, if for example, like if you have a database, you can store lots of information from like long ago, and that's fine. But you don't want data that has recently changed and it hasn't changed in the update. So you want the database to always be up to date. Unless for some reason you're storing like an archives, let's say you have a store and you want to store an archive of every single order you've ever made or sold or whatever, well then you can store all that in a database and that doesn't really need updated because it's an archive. But if you have a customer in your database and the address is out of date and doesn't update, well then you have a problem. Another example is if the person if your database is designed badly and you have repeating data, well then one example of the data can update and the other one's left behind. So now you have like two addresses for one person, which should just be one address. That's another example of a data integrity problem. So we'll be getting into like specific cases of data integrity problems as we go on. But when we talk about database design as a whole, people usually break it up into 3 sections. 2 or 3, it just kind of depends on like what people, I mean it varies from person to person. So okay, first we have the conceptual, and then we have the logical, and then we have the physical. Alright, these are all known as schemas or schemas, however you want to pronounce it, but that's this. Alright, so we have the conceptual schema, the logical schema, and the physical schema. A schema, or just think of a schematic, like when you're building something, it just tells you the way the data is structured. The conceptual, this up here is when we're just kind of thinking about things, how things are related. We don't think of limitations as in, oh, we're not going to be able to do that because we only have this much availability or something. This is kind of like unlimited brainstorming phase. And as we move down, this is more specific to where we say, okay, this is how we're going to program our database. So up here, this up here is more general. This down here is more specific. Once you get down here, you have to start worrying about, alright, what kind of relational database management system am I going to use? But when you're up here, you can just kind of think of general concepts, how data is related. So the farther you go down to the physical, the more specific things get. I mean, that's pretty obvious. So rather than thinking of it like 3 steps, I kind of think of it as a continuum. We are taking our general ideas and moving them to specific implementations. Hopefully that makes sense. But basically, when we talk about these individually, the conceptual just talks about how data is related, because in a relational database management system, we have relationships between tables. If you think of, we have a users table, and then we have a sales table. And these users can go to this website and buy products. That's our example here. It can be anything, but this is just an example. Well, every single sale has to be bought by someone, specifically one user. So that means there's a connection between the user and the sale. So we have this connection here. That is part of the conceptual design. We say, this table, the sales, depends on the user. So that's because without a user, we can't have a sale because there's no one to buy the stuff. And a user doesn't necessarily have to have a sale. So it's dependent this way. That would be the parent, that would be the child. Hopefully that makes sense. When we get to the logical, we start planning out our table structure. So we have all these relationships between data. Well, then we can realize, all right, we have specifically a user's table. And we have X number of columns, the username, the password, the ID, the address, the phone number, the credit card information if that's something you need to store, anything like that. Then we have another table, and it is the sales. So we have the sales table. So we have user, the user table, and then we have the sale table. And then this is connected in some way. So we have a user can have multiple sales, and a sale can only have one user. That's logical database design because we're actually structuring our columns, our data types, our relationships. We're drawing those out, so we have this logical drawing or schema. The physical, that is when we start actually implementing that into a database. So when we're talking about just designing and we're not actually creating the database, the physical design would be figuring out what relational database management system will work best, what are our table types, what server are we going to store this on, how are people going to access this? Is it going to be over the internet? Is it going to be over computers, programs? So usually a database will be on a server, and this will be accessed by multiple different people. That's because the database is like the core of all data. For example, if we only had this one person using the data, well then we wouldn't need this huge database. We could just store that information on their computer because they're the only one on there. It doesn't even make sense. So typically, everything's kind of accessed on a server. So the physical would be, okay, what kind of server are we using? How are people going to access our data? Is it going to use a web form? Is that something we need to program? And then when you physically implement that, that's when you actually program the database, build the web form or whatever you are doing, installing the server and testing, building the users, who's going to access it, the views, what are the different views going to be, what data is going to be returned, and so forth. This is also when you really focus on security, because logically, when we're in the logical phase, we're still kind of thinking, okay, no one's going to try and break it. No, everyone's going to use the database correctly. But in the real world, that doesn't work out that way. People, either they try to break things, or they just don't know what they're doing, or there's errors, or there's incorrect data. Well, that's when, somewhere along this continuum right here, is when we need to start worrying about security. We don't want people breaking into our database, and we don't want our database to fall apart and have data integrity issues. So hopefully that clears some things up. So the database design, just to sum things up real quick, database design is using skills that you know to build a database that is not going to have data integrity issues, update anomalies. We'll talk about those too, but that's basically when, if for some reason you're storing two of the same data, like if my address is in the database twice, well that's a problem, because when I update my address, only one may update, for example. And now the address says I live in two different places. That's wrong. So a database design is a method to separate information over multiple tables, rather than having one huge table like this, where I store my address, we store our sales, we store our customers, we store our favorite video games, we store our relationships with, yeah, you get it. So basically, this is a bad design because it's all in one table, and when I have to update it, so we have, let's just say this is a row, right? And I have, the columns are ID and username, and then we have, this is going to need to be a little bigger, and then we have username, we have address, here, let's go phone number, it's easier, phone, and then we have favorite color. When we store it like this, well, if we need to put a new favorite color, we have the ID 7, that's me. We have the username Caleb Curry. We have the phone number 1-800 ... Favorite color camo. And then if I want to put a new favorite color in, well, we can't because we don't want to. We already put one in there, so we need to create a new row. Say 7 Caleb Curry. 1-800 ... And then favorite color green. No. Red. Well, now we have all this duplicate data. We have this in here twice, we have this in here twice, we have this in here twice, and we have to have two rows for favorite color. So you have to find a solution to this problem. But now, if I decided to update my phone number because I got a new phone number, well, now I'll update it and I'll change it to 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever it is. Well, now I updated my phone number, but for some reason we have a data integrity issue because my phone number is in here two different ways. That's a bad database design, And in this series, we're going to be talking about fixing problems like that. And the best way to do this would be to like separate it into multiple tables. Plus, you probably don't need to store your favorite color unless you're running some kind of like art website or business. So it's possible, but we can do the same thing with like orders. How many orders? If I had to put my orders in that table, which is another bad idea, we have the same data integrity issues. So this series is going to talk you through getting rid of those data integrity issues so you have the best database design for best performance. We're going to be talking about data integrity. Alright, so what is data integrity? We talked about it a little bit in the last video, but this video is going to be going over it in more depth. Data integrity is just having correct data in your database. So when we're databasing, we don't want repeating values, we don't want incorrect values, and we don't want broken relationships between tables. For example, in the last video I gave the example, you have a table here, and this is the user table. This is weird writing like this. And then we have a table over here, and that is the sale table, which is where you sell products, for example. This is just an example. You can implement other examples, but this is just to illustrate my point. A sale is when a user buys product. That means a sale needs a user as the buyer. Otherwise, there's no sale. We can't have a sale if no one bought it. Does that make sense? That means the sale is dependent on the user, and we have a relationship. The user buys stuff. Stuff is bought by a user. This is known as a, can you see this? This is known as a relationship. Now, do keep in mind that the term relational database does not come from the word relationship. It comes from relations, which is the mathematical connection of sets, which we talked about that in the earlier video, but just don't get that confused. But relational database does have relationships between tables. So this, if for some reason this was broken, and now we have a sale that was bought by a user or no user. So for example, let's say this sale was bought by user with the ID of 7, okay? And then we have a user of ID of 7. So there's a connection. The sale was bought by the user of ID of 7, which points back to the user. Make sense? That's data integrity. But if this relationship is broken, and it says this sale was bought by the user with the ID of 7, and then this person is removed from the database, well, now this sale points to a table or a user that doesn't exist. And that might be practical in some sense to say that sale was bought by that user when he did exist. But for things that need to update consistently, we don't want that to happen. So that's an example of an integrity issue. So you want to keep that relationship to say, okay, well, we got rid of the user. We need to update the sales to say, well, either the person is deleted or also do something with the sales. So, yeah, sorry if that was a little confusing. Okay, so the three main types of data integrity. First one is entity integrity. We talked about entities in like one of the first few videos. An entity is anything we store data about. So we had the user to begin with. This is an entity. What it means by entity integrity is basically unique entities. When we have a user, we often give them IDs. This is known as a key. So an ID is used to enforce uniqueness among the entities. Like for example, if we had a table for users, and we store the name of the person, and then we stored their address. No, let's just go to their phone number. Yeah, sorry. Because when we talk about addresses, it's best to break it up into like street, state, and I don't want it to go through all that. So we could potentially have a person with a repeating name. So let's just say his name's Caleb and his phone number is 1-800-YOU-WISH. Alright, well, if we had another person, if they both lived in the same house, for example, and this was their house phone, well, sometimes people will name their children the same name as them. So now we have two people with the same phone number. And you look at this and you say, okay, well either we have two people with the same phone number, or we have two rows talking about the same person. And we don't know, because we don't have proper data integrity. So a way to solve this is to either add more columns to where the row would be unique, such as a social security number, or we could add an ID column, and this would be like 6 and 7. So now we're talking about two separate entities. This is talking about this guy because his ID is 7. This one is talking about this guy because his ID is 6. They're two separate entities. That's entity integrity, having uniqueness among your entities. We have uniqueness with the rows, and we also have only one user table. We're not going to have another user table because that information should go in the original user table. On to referential integrity. This is the one we talked about earlier, is when we reference the ID of a table in another table. If we had a comments table on the website, right? And we say who the comment is by, we have a user ID which points back to this ID over here. That's because the comment has to be posted by a user. Otherwise, we have a comment that didn't have someone who posted it, which doesn't make sense in the practical world. So we always have to have referential integrity, which basically says every time there's a comment, there needs to be a person who posted that comment. And that connection needs to remain. It needs to stay. If for some reason this is disconnected, and then this user is removed, or this table is changed, well then this could change. I mean, this stays the same, and then there's a disconnection to where this is changed, and this is old, outdated data, where either the user no longer exists, and the comment still says he does, or something else like that. That's referential integrity. And that'll make more sense once we start designing and stuff. But yeah. Domain integrity, that brings up a new word, domain. Domain is basically just the acceptable values for a column, per se. It's what we are storing, the range of what we are storing within a database. So when we're talking about tables, we have columns. So these columns up here, let's say we have a phone number. Well, that means we should have a certain number of digits. We have the area code, and then the 3 digits, and then the 4 digits. And that's at least the US. It might change other places. But that is 10 digits. So we know that the phone number should be 10 digits, and it should be numbers. So if for some reason I put the word cake in the phone number column, well, for one, this is going to cause an error if we have domain integrity, because it's not a 10-digit number. It's just a word. That's not the proper domain. It's not a digit, it's not numbers, and it's not 10 of them. So we know that's going to cause an error. So that's the basics of data integrity. When we don't have data integrity, we have errors. When we have data integrity, we do something to correct those errors, such as saying, oh, these all need to be numbers. That's how we implement data integrity, by setting database rules. And how you do that with the database, well, that kind of varies upon the relational database management system that you use. Some relational database management systems allow for general rules saying, okay, this has to be a range of this numbers. Some of them are more vague where they only allow you to implement data types. Data types would be like integer 10 digits. So when we talk about practically implementing data integrity, different relational database management systems have different things you can do. Almost every single relational database system that I know of, I'm pretty sure all of them, but who knows, they allow for data types. So a data type is pretty self-explanatory. It's the type of data. So in database, we classify things as generally integer or text or date. So we either have numbers, text, or dates. That's like 3 general categories, which we'll be talking about that more in a future video. But the data type can put limits on what we're allowed to store. For example, we can say, okay, we only want a character column with the maximum of 20 characters. That means we can put a string in the column that says, I like pizza, yeah! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That'll fit. But if I wanted to change this pizza to lasagna, well then I just added a couple extra characters. That might cut it off. I'm not sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's the maximum we could put in that data type. That's an example of implementing that data integrity for the characters. So this will be for the domain integrity. We can also have referential integrity with what's known as foreign key constraints, which allows us to connect tables. Because when we draw tables, we could say that they're connected in some way. But how do we enforce that in a database? We use foreign key constraints. For example, we can say if this is the parent, let's say this is the users, and this is the comments. The user places a comment. So this is the parent, this is the child, because the child can't exist without the parent. You can't have a comment without a commenter. Well, using foreign key constraints, we can say, alright, if this user gets removed, also remove all of the comments by this user. That's an example of foreign key constraint. As for the non-repeating data, that is done with just designing your database in the best way. So yeah, I know that video was kind of jumped back and forth from concept to concept and maybe a little confusing, but I'm sure you'll get it as time goes on. I just want to do a little bit of review as well as go over the vocabulary that we've learned. So if you don't really want to know, we're going to go over some new ones too, but if you don't want to review, then feel free to skip this video and the next one. So this video will be about data and database design terms. So the very first term we learned was data. Data is pretty much anything we store in a database. You pretty much know what that is, so that one's pretty good. Database, that is what we store our data in. And then we have a specific kind of database, which is a relational database. And what's special about a relational database is that it stores things in tables. We have a database management system, or database managed, DBMS for short. That is how we manage a database using code. That's how we control our database. we have a specific kind of database management system called a relational database management system, which is just used to control our tables and the values within our tables of a relational database. Pretty simple. Now we're going to introduce a new word to you, which is null, or null, however you want to pronounce it. I've been told I pronounce it wrong, but I don't really care. Anyways, this is when someone does not enter a value within a column on a table. So if we have a table and we have something such as fax number, well, not everyone is going to have a fax number. So when we have a guy, let's say we have an ID here, we have a guy with the ID of 7, and we don't have a fax number, this emptiness is said to be null. So basically, you'll hear empty value, although by definition, null means no value, so it's kind of a bad definition, but who cares? Null basically means there is no data in that specific field. And we'll be getting into more terms like that in a second. So that is what null means. That's one you will need to know. Another one is an anomaly, or anomalies. So, anomalies are basically errors within our data, our data integrity. So when we have an anomaly, it's something that goes away from what we expect or from the normal. When we update something, for example, and instead of updating one column, it updates 10 and it wasn't supposed to, that's an anomaly. So yeah, you'll need to know that as well. The other one is integrity. We implement database integrity to protect against anomalies. So we went over 3 different kinds of integrity. We went over entity integrity, we went over referential, and we went over domain. Real quick what these are. Entity integrity is saying uniqueness among the table. Referential keeps the connections, the keys, foreign keys, primary keys, they keep them connected across multiple tables. So we could say these 2 tables have some kind of connection. And then domain is basically saying a column within a table has all of the expected values. So we have a phone number, we would expect numbers, not text, or not a date. That is domain integrity. And the word domain is basically the range of values that are acceptable to store within a column. So these are our data vocabulary that you should know. Now we're going to move on into the design terms. Yay. Okay. So designing is what we're here for, so this is fun. Very first thing you need to know is an entity, which is anything we store data about. A user, a mortgage, a transaction, a credit card information. Anything, the comments, a comment. They're all entities, it's what we're storing data about. Then we have attributes. Attributes are the things we store about the entity. A comment, an attribute of a comment would be the date that it was made. The length, how many characters is it? Who posted it? That's an example of an attribute. A relation, if we're talking about mathematics, it's a connection between 2 sets of data. When we're talking about databasing, put very simply, it's just a table. So a relation is another name for a table, where we have data within our database. So we can have a structure of different tables. So these can be connected. Just, I don't know, however you want to connect them. This can be our database. Well, each one of these different sets of information or data is known as a relation. It's a table. Next term is a tuple, however you want to pronounce that too. I'm just winging it here. That's another thing for a row. It's all of the attributes about a specific entity. So if we have this guy, we can say his name is Caleb, his phone number is blah 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 blah, his address, his age, his birth date would probably be better, how long he's been a member of this website or whatever it is. All of these values about this entity, that's what that is, a tuple. That would also be a row on a table, because we physically represent relations with a table. So when we have a table, we have the columns, so we have name, phone number, address, social security number, and then when we enter all of those for a specific person, we have the ID of 7, the name Caleb, the phone number, blah blah blah, the address, blah blah blah. That is known as a tuple or a row. Another term is a table, which we just talked about that, which is just a physical representation of a relation. Tables are what we store in a database to organize. Am I like cutting my head off there? Can't really see. To organize our data. Within a table, we have rows and we have columns. The rows would be a specific individual entry within our table, so like that guy we just drew, all of his values would be his row. The columns are that specific, a specific attribute of that person, such as a name. This is the column where we would put the value Caleb. Alright, now we also have another three more terms that we haven't learned yet, which you will possibly hear. They're kind of older terms, but they're just talking about the same thing. You may hear the terms file, record, and then field. So what are these talking about? Well, file is just another name for a table. A record is another name for a row, and a field is another term for a column. So other than that, we have the words value. A value is the information that we put in to a specific column. So here is a value, Caleb, or subscribe, or 700, or June 16th, whatever it is. Those are all values. Alright. Oh man, it's already 10 minutes. Dang. Alright, then we have an entry. You may hear the term entry, which I like to use this for it's almost like a verb. When you enter data, you get an entry. So basically an entry is just another name for a row. So there's obviously a lot of similar names, and we'll be making a table saying what word. Just give me a minute. Database design. The process of designing your table to remove anomalies and have data integrity. Schema or schema, however you want to pronounce that. That is just a drawn out structure of our database. Then we have a new term here. It's called normalize or normalization. Normalization is basically just a bunch of steps that we're going to follow to help us get the best database design. So that's part of database design when we go through these normal forms to get the best database design. We'll talk about that more in an upcoming video. But I want you to know that the term normalization is the process of building the best database design. The other one, naming conventions. A naming convention is just a consistency used to make things consistent. So we name tables a certain way, we name columns a certain way, we name our database a certain way, we draw our database schema a certain way. So basically, convention is anything that is done repeatedly to create consistency. And the last one here is keys, which I'm not sure if I talked about this or not yet. I think a little bit, but not much. A key is something to make everything unique within a table. This is how we make connections among tables. We connect IDs. We may say, oh, this comment was posted by the user with the ID of 7. Well, that points back to the user table. We do all of that with keys, and we'll learn more about those as time goes on. Alright, so you see we have a lot of terms, and a lot of them are repeats for this meaning the same thing. For example, we have a relation, and then we have table, and then we have file. So relation, table, and file are all talking about the physical structure, a table, pretty much. A record, I'm going to circle these ones. A record would be a row, so we have a row, and then we have a tuple. These are all talking about rows within a table. And then we have, how should I do this? Let's cross them out. We have columns, and then we have attributes, and then we have a field. Those are all talking about a column in a table. And also entry, you can kind of think of that as a row, because you enter data into the table and you get a new row. A value is just a specific, you can think of it like, let me erase some of this. We have this table and we break it up into columns. So we have ID, name, and then phone number, for example. Those are our column headers, and then we have specific values. 7, Caleb, and then we have another guy, 8. Well, if we separate this into cells, which is another term, we have a specific value that we put in here, such as John. That is a value. Now, entity, that's the only one that's, so we just went over value. Entity is what's left that's not circled or crossed out or squared or something. Entity is, I don't like to really assign this to like a row or a table or anything, because an entity is just something we're storing data about. So that could be an individual row, or it could be the table type. So for example, we have a table for users. Well, the user is the entity, but a specific entity would be a row within this table, because we'd have the entity for this guy over here, and then we'd have one for this guy down here, or for this chick over here, or lady, I should say. So these all get their own rows, you see. So an entity, that's just something we store data about. This video will be just some more vocabulary. There's not as many. We're broken up into two categories. The first one is SQL. So first we learned about SQL, which obviously is a programming language used to, by the way, I never even mentioned this, I'm horrible. Structured query language is what SQL means. That's what it stands for. It's used to connect to your database. Oh, sorry, I just got distracted. I was waving this paper, and like my lens is like flashing for some reason. Anyways, the next part was data definition language, which is used to define, it's part of SQL. So SQL has data definition language and DML, data manipulation language. DDL is used to define the structure of our database. Data manipulation language is used to insert values in our database, as well as update them, delete values, and search values, and so forth. The other thing was, I didn't really mention this, but I do want to mention it here. SQL keywords. So anytime we have the word keywords in a programming language, it's talking about something that is reserved that you're not supposed to use for your user-defined data. So for example, select in SQL. This is a word that your database is going to recognize as, okay, we want you to do something, we want you to select data. It's a keyword because it's already defined. So I don't want to name my tables or my columns any keywords because it can cause errors or confusion or just make things complicated. I always put SQL keywords in capital letters. Alright, so that's pretty much all for the SQL. Here's my eraser. Go America. And every other country. Alright. Presentation. So the very first thing is we have the front end of an application. So the front end is what the user sees. The back end is what's going on behind the scene. When we have a website, we don't just have what the website looks like. We have code that gives us that look. When we put in data to forms, we have languages that communicate with databases to create a easy to follow, non-confusing front end. But the back end is complicated as heck. So that's the difference between front end and back end. Front end is what any user at a particular time will see. The back end is what's going on behind the scenes. So often when we're working with databases, we will program a front end because we don't want everyone accessing our server. It's insecure and it's just not a good idea. So we often create a front end application to access our database. Most commonly a website, although there's other forms, but whatever. So if here's our database, rather than people signing into the server and using SQL code to get information, we often program front ends for people to access this data in a different way. So each one of these front ends would be like a website page, for example. So here would be a registration page, here would be your users page, here would be your profile, your home page, here would be, if you like, you can even have different tier systems. So this could be a page where the website administrator can add or delete users. They have that extra privilege. This is also the view system, which we will talk about in a second. Well, the front end doesn't allow us to directly type in our own SQL. It only allows us to use what the front end gives us, which is then communicated to the database. So that's what a front end is. The back end would be the server-side code used to communicate with the database. So when we're talking about clients and servers, we have those two terms. We have client and then we have server. So very first thing is client. Client is, think of it if we have this wall here. Over here we have a computer. And then over here we have the database. This is the client side because we're accessing the database. Over here is the server side. So client side and then server side. I don't really have room to write that, but yeah. The server serves instances of this database to the client where they can access the data in some way. Depends on how the privileges we give them. So when we're talking about different privileges for different people, we use what's known as a view. So first let me finish this. Client side and server side. And we communicate from the client side to the server side by a server side script. scripting or programming language. Oh, that's huge. Whew, now my hand's tired. We can give custom views. So a view is just taking the data from the database and illustrating it in a different way than how it's actually stored. For example, a user on a website can visit, let's say we're on like a social network and I visit my friend's page. It'll tell me their name, possibly their username if that's what they use, their data registration, their phone number if that's public, for example, anything like that, their relationship status. Although information that is private may only be accessible to the user who owns it. For example, their password or their email or their friends list. That might be a different view depending on what page you are on, and the user that you are. So I may be able to access my own password and email, but that might be private to other people. That's the view. Views often use joins, which basically connect data from multiple tables to create a new table. If we have two tables here, users table, comments table. Can you see that? Can you see it? You better be able to see it. Well, a comment is always given by a user, and we connect it using the ID. It's called a foreign key connection. Well, this ID, let's say it's the ID of 25, right? Well, instead of having, okay, this comment was by the person with the name, with the user ID of 25, we wanted to say Caleb Curry. So we have a join taking the name from the user table and connecting it with the comment of the comments table to get this new generated table. This is just a view. It's not actually stored in the database like this. We're just creating a new illustration of how the data really is stored. And then we can have the name of the person followed by the comment or comments of that person. You may be asking, why don't you just use the name as a reference? Well, that's because multiple people can have the same name, for example. So we always need something that's unique for this connection. Whether, if you don't want to use an ID, you could use something like a natural key username, for example, but I often use IDs, and we'll be talking about that more in upcoming videos. So yeah, that is all of the vocabulary that we have gone over so far, pretty much. If you have any questions about any of those, just leave a comment. I recommend that you write all those down. I should have told you that at the beginning. But anyways, I recommend you write those down as well as the definitions. Study those, learn them, and especially study from the previous videos. Study all the different terms that mean the same thing. Because after a while, you get kind of used to those terms. But if you're just learning and you don't know that these are talking about the same things, well then you can get confused very easily. So I recommend you study, alright, a row is also called a tuple and is also called a whatever, blah, 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 blah. That will help you, that way when I say whatever word it is, you know what I'm talking about and you don't have to like check your charts or whatever, or go watch other videos. So that's something I definitely recommend that you memorize. As well, for the SQL stuff, it's not as important, like the DML, DDL, but I do recommend that you memorize all of these terms as well. We'll be talking about atomic values. So, atomic values basically just mean that it means that the value stores one thing. Everything we store in a database should be one thing. When we have columns, they're about one thing. All of the values within that column are one thing. We have a column name. Well, what does a name consist of? You can have a first name, middle name, and last name. Well, although we're talking about one thing in name, it's not really necessarily atomic, because we're storing 3 names within one name. So if we wanted to make this atomic, the best thing to do for database design would be to break this up into first name, middle name, and last name. So now we have Caleb, Daniel, Craig. 3 separate names, right? Alright, so when we do store things in a database, we want to try to make them atomic. Now, we don't want to go to the extreme where we break everything apart to where it doesn't even make any sense. But just think of like atom. An atom, atomic, when this word came about, we never really split an atom, so we thought of an atom as the smallest indivisible, I think is the word, piece of information in this world. Now we can split it, but whatever. So sometimes you may think, oh, this isn't really a good term, but everyone will still use this term. So just think of atomic as the smallest one individual thing stored. Now we don't want to go to the extreme. For example, if we have the word subscribe, this is a word. It's one word. Don't go to the extreme where we separate it into like individual letters, because that'd be ridiculous. It's like, alright, we store in a table, instead of having first name, last name, we have first letter of the first name, second letter of the first name, third letter of the first name, fourth letter of the first name. That doesn't make sense. We want to break it down until we can treat it as one thing. For example, a phone number, it often has an area code. Well, we don't want to break a phone number up into multiple portions. I often just store phone numbers as one because you treat it as one thing. When it comes to addresses, well, an address consists of like multiple. We have a street address. We have a city, and then we have a state. We have an area code, or zip code, I mean. So addresses, I often break those up into multiple columns rather than storing one address with 1, 2, 3, Epic Lane, Legit California, 73821. Rather than storing all of that in one column, I break this up into street address, city, state, area code. And then that allows us to run more complex queries on our data because we can select all of the users from the state of California, or we can select all of the users who live in this city, or pretty much anything like that. So this is part of one of the normal forms, which we will be talking about in the future. But as for now, just think of storing everything as one. So not only do we want the column to be about one thing, like an address is just an address, or a phone number is just a phone number, but we want the values within that to be singular as well. For example, we could have a column, favorite movies. This isn't going to work because within that column we could store unlimited movies, and that is also improper. So that's not going to work as well. Every single column header should be singular, favorite movie. And you may be asking, well, how would you store multiple movies? Well, that has to do with more complex relationships, and that is something we'll be talking about very shortly. But the solution is not to store multiple things within a column. This video will be about relationships. And I don't mean relationships as in dating advice, because I probably couldn't give any of that. But Besides that, we're going over database relationships. So what is a relationship? Well, in a database, everything is connected. Think of it like a giant web. Somehow something is connected to something else. Rather than storing everything in a giant table, sorry, my board's kind of wet, so it's not really writing very well. We split that, and then we have two smaller tables for manageable data,